So let's review right triangles and then build into trig basics. This is a right triangle because it has the symbol here, and having that box in an angle tells you automatically that it's a right angle, otherwise known as a 90-degree angle. All right? Now, looking at this, every right triangle has a hypotenuse. A hypotenuse is the longest side of a triangle. It is the side that is opposite the right angle, like this. If you think of the right angle as an arrow, it points to the hypotenuse here, right? And if I were labeling my right triangles, I could just use an H to label my hypotenuse. It's important also to be able to talk about the other two sides of a right triangle in relationship to a specific angle, which we're going to call theta, all right? And that's this angle right here. The measurement of that obviously would be in degrees. And in relationship to this angle here, there are two sides beyond the hypotenuse that we need to label. And we can look at the side that is opposite the angle. So this is our opposite, or sometimes you can just label that with a big O. And then there, of course, is the last side here, and that one uses the terminology which means next to, and the word next to, another word for next to, is adjacent. So the base here of this triangle happens to be the adjacent side to the angle that we're talking about. The vertical, the perpendicular to the right angle here, is actually our opposite side. And we have our hypotenuse, the red side here. So for any right triangle that you are given, you need to be able to identify that, regardless of the orientation of the triangle. So if the right triangle is this, you need to be able to label hypotenuse here, right? Adjacent, oh, we have to know what angle we're talking about, right? You have to know the angle. So I'm going to tell you that the angle is, and this could be just a variable of x, for example. So in relationship to that x, which one is the adjacent side? We're going to use the side that's not the hypotenuse. Remember, it can't be the hypotenuse. That's my adjacent side. And then my opposite side is this one. Let's do one more quickly. Take a second and figure out for yourself which one is the hypotenuse, which is the adjacent side, which side is the opposite side. Remember, we're using the reference point of the angle labeled y here. So your hypotenuse, this is like an arrow, right? This is your hypotenuse. Your adjacent side is this one. You're getting this, right? And here's your opposite. We need to know this because we're going to calculate using these trig ratios of sine, cosine, and tangent to figure out what to calculate problems. Okay, so we're going to be solving either within right triangles, we're solving sides, unknown sides, using other information of the triangle, or we're solving for sides using other information of the triangle. Did I just say that? Angles using other information of the triangle. So we need to know our trig ratios. SOHCAHTOA, sine, cosine, and tangent. Sine is the relationship between opposite, and this is a fraction here, opposite over hypotenuse. Cosine is the adjacent over the hypotenuse, and tangent is the ratio between the opposite and the adjacent sides. It's opposite over adjacent. And this is where I come up with, and here's S-O-H, ka, toa, right? SOHCAHTOA. Memorize this. And the best way to actually write them is as an equation. Sine equals opposite over hypotenuse. Cosine equals C equals adjacent over hypotenuse. And tangent equals opposite over adjacent. Okay? So the first thing you do when you come across a problem is you want to find out what kind of triangle is it? Because if it's not a right triangle, we can't use our trigs, right? So it's a right triangle because we see our little right angle sign here. We want to identify the sides. So we want to go through and say, well, I know this is the hypotenuse, and according to this angle, this is the adjacent side, which makes this one over here the opposite side. So I've labeled my O, A, and my H. And then I figure out, what am I going to use? How can I solve for this? I need to find out, let's say we're trying to solve for the adjacent side. Here, let's say that's the x in the problem that's given to us. What you do is you start with the information you know. You know the hypotenuse, you know you're solving for the adjacent, and you know you have an angle. So what you're going to do is look at your options of SOHCAHTOA, and you're going to ask yourself, which of these uses the A and the H? Does sine use it? Nope, it uses opposite and hypotenuse. Does cosine use A and H? Yes, it does. So that's the one I'm going to use. And just to check, tangent uses opposite. No, I don't have the opposite. That's not even a factor in this problem. So I know that I'm going to use cosine because I have an opposite and adjacent to work with. And how I write this out is I write cosine of the measure of the angle, cosine of 20, and I'm putting it in parentheses because that's how it goes in your calculator, okay? Cosine of 20 equals adjacent over hypotenuse. And notice how in this case I'm using the actual variable and numbers from the problem. The way you solve this in your calculator is if this had been an algebra problem, right, we would have cross-multiplied these. So I'd be multiplying this times this, cos 20 times 3, and x times 1. So that's what I'm going to do. So my x equals, which is great because I want to solve for x. And in my calculator, I'm going to put cos of 20. Make sure you draw in. I'm going to write this in a different color so you see it. You have to draw in, right into your calculator the other parenthesis. Your calculator, when you hit cos, will provide the first parenthesis, but in your calculator, you have to provide this closing parenthesis here. And then you're going to hit multiply, right? And then times 3. And when you get that answer, with this long decimal here, what we're going to do is change our notation to x equals approximately, and we're going to use 3 significant figures, 2.82, and let's say this was all in centimeters, I would say centimeters afterward. It's always good, sweethearts, you need to check that this answer makes sense, all right? And in this case, we're like, okay, let's look at it. I know that this side is 3 centimeters, and it's the hypotenuse, and it's the longest side, so both the opposite and adjacent sides must be shorter than 3 centimeters, right? They can't be longer than 3 centimeters because that would be an illogical answer. So you've got to use your logic and say, well, does this make sense? I have an answer of 2.82 centimeters approximately, right? Is that less than 3? Does that seem reasonable? And it does. Okay? So that's probably right, and I could check my answers to be sure. You have enough information now to work in Chapter 12, all right, on our Unit 2 plan. And what you need to be doing is starting at the beginning of that unit with the simple labeling and setting up the fractions and then going into solving, all right? So get started on that good easy stuff first at home, and then we'll do some more real problem solving in class when you come on Monday.